Imagine travelling billions of kilometres away from Earth, past the planets, beyond Pluto, beyond the reach of sunlight as we know it, to a place where the sun itself begins to lose its power. A place no human has ever seen, a place where our solar system ends and the unknown truly begins. Now imagine that something was detected there, something unexpected, something that challenged decades of scientific predictions. In 1977, a small spacecraft was launched with a simple mission. It was never meant to rewrite physics. It was never designed to explore the space between the stars. And yet today, Voyager 1 is farther from Earth than any human-made object in history, sending whispers of data from the very edge of our sun's domain. What it discovered at the heliopause, the boundary between our solar system and interstellar space, left scientists stunned. Magnetic fields behaved strangely, cosmic radiation surged, plasma waves echoed through what was supposed to be silent emptiness. Even experts at NASA did not expect what the data revealed. Tonight, we are not just talking about a spacecraft. We are standing at the frontier of human knowledge. We are confronting a mystery at the border of our star. And before this journey ends, you will understand why this discovery is not just about space. It is about the unstoppable power of curiosity. Stay with me, because what lies at the sun's boundary may change the way you see our place in the universe forever. Eyes at the farthest reach of our solar system lies a boundary so vast and invisible that it feels almost mythical, the heliopause. This is not a wall made of stone or fire, but a dynamic frontier where the sun's influence finally meets the raw immensity of interstellar space. Our sun constantly releases a stream of charged particles known as the solar wind, a powerful outflow that travels billions of kilometres in every direction, carving out a protective bubble around the planets. This bubble is called the heliosphere, and it shields Earth and its neighbouring worlds from a large portion of dangerous galactic radiation. But like all forces in nature, the solar wind weakens with distance. Eventually it slows down under pressure from the interstellar medium, the thin mix of gas, dust, and magnetic fields that exists between the stars. The heliopause forms precisely at the point where the outward pressure of the solar wind balances with the inward pressure of interstellar space. It is the ultimate border of the sun's dominance, the place where particles from our star can no longer push back the galaxy. Beyond this threshold, the environment changes dramatically. Temperatures, particle densities, and magnetic influences shift into something fundamentally different from what exists inside the heliosphere. When Voyager 1 approached this boundary, scientists expected a clear, sharp transition. Instead, what it revealed suggested a far more complex and turbulent frontier, hinting that the edge of our solar system is not a simple dividing line but a fluctuating, living boundary, shaped by forces we are only beginning to understand. Explained in 1977, a small spacecraft began a journey that would outlive presidents, technologies, and even generations of scientists. Launched by NASA, Voyager 1 was originally designed to study Jupiter and Saturn during a rare planetary alignment. After completing its primary mission with stunning discoveries, active volcanoes on Io, intricate rings of Saturn, and detailed images of giant storms, it did not stop. Instead, it continued moving outward, carried by gravity assists and its own incredible momentum, heading toward a destination no spacecraft had ever reached. Decades later, in 2012, Voyager 1 crossed the heliopause, becoming the first human-made object to enter interstellar space. This historic crossing was not marked by a dramatic visual change, but by subtle shifts in particle counts and radiation levels. Instruments on board detected a sharp drop in solar wind particles, and a sudden rise in high-energy cosmic rays from outside the solar system. The spacecraft had moved beyond the Sun's protective bubble and into the vast ocean between the stars. Travelling at more than 17 kilometers per second, Voyager 1 continues to send back data using technology developed in the 1970s, powered by a slowly fading radioisotope generator. Its signals take over 20 hours to reach Earth, yet they carry priceless information about a region humanity had only theorized about. Voyager 1's crossing transformed science from speculation to direct measurement, proving that human curiosity can extend far beyond the boundaries of our own star and into the silent depths of the galaxy. When Voyager 1 crossed beyond the heliopause, scientists expected silence, a quiet emptiness, marking the end of the Sun's influence. Instead, the spacecraft detected something astonishing: plasma waves rippling through interstellar space. Plasma, often called the fourth state of matter, is a hot, electrically charged gas that makes up stars and much of the visible universe. Even in the near vacuum between stars, thin traces of plasma exist, and when disturbed, they vibrate like the surface of a cosmic ocean. Voyager's instruments picked up oscillations in electron density, translating invisible electromagnetic activity into measurable signals. It was as if space itself was humming. These plasma waves were not random noise. They were triggered by powerful solar eruptions that had travelled outward for months, eventually reaching the boundary region and beyond. When those shock waves interacted with the sparse interstellar plasma, they caused it to oscillate, revealing its density and structure. By analyzing the frequency of these vibrations, scientists were able to calculate the density of particles in interstellar space for the first time through direct measurement. The results were surprising, suggesting that the region beyond the Sun's protective bubble was denser than expected. This discovery challenged earlier models and reshaped our understanding of how our solar system interacts with the galaxy. Instead of a silent void, Voyager revealed a dynamic, responsive environment where even distant solar storms can stir the fabric of interstellar space, exposing a hidden symphony playing at the very edge of our stellar neighborhood. One of the most puzzling discoveries at the Sun's boundary involved magnetic fields, the invisible lines of force that shape the behavior of charged particles throughout space. For decades, scientists predicted that when Voyager 1 crossed the heliopause, it would detect a dramatic shift in magnetic field direction. Inside the heliosphere, the magnetic field is dominated by the Sun, carried outward by the solar wind in a vast spiral pattern created by the Sun's rotation. Beyond the boundary, however, the magnetic field should belong to the galaxy itself, oriented differently and independent of the Sun's influence. The expectation was clear: crossing into interstellar space would mean entering a completely new magnetic regime with a noticeable angular change. But when Voyager 1 made the historic crossing, the magnetic field direction did not swing sharply as predicted. Instead, it remained surprisingly aligned with the solar magnetic field, even though other measurements confirmed the spacecraft had entered interstellar space. This unexpected continuity created a scientific dilemma. How could the spacecraft be outside the heliosphere, yet still detect a magnetic field that seemed connected to it? The data suggested that the boundary between solar and interstellar magnetic domains is not a clean break, but a complex transition zone where fields may drape, twist, or merge in ways not fully understood. This finding forced researchers to reconsider long-standing models of how magnetic fields interact at cosmic boundaries, revealing that the edge of our solar system is shaped not by simple separation, but by subtle and intricate magnetic dynamics. As Voyager 1 approached and eventually crossed the heliopause, One of the most dramatic changes it recorded was a sudden surge in high-energy cosmic rays. Inside the heliosphere, the Sun acts as a powerful shield. Its solar wind and magnetic field form a protective bubble that deflects many of the charged particles constantly travelling through the galaxy at nearly the speed of light. These galactic cosmic rays originate from extreme cosmic events such as supernova explosions and other high-energy astrophysical processes far beyond our solar system. For decades, scientists understood that the heliosphere reduced their intensity near Earth, but they had never directly measured what lay beyond that protection. When Voyager 1 moved past the Sun's influence, its instruments detected a sharp and sustained increase in cosmic ray intensity, confirming that it had entered a region where the galaxy's radiation environment dominates. The change was not gradual, it was sudden and unmistakable, like stepping from a sheltered harbour into an open, stormy sea. At the same time, particles from the solar wind dropped dramatically, signalling the end of the Sun's outward control. This surge revealed that interstellar space is far more energetic and radiation-rich than previously experienced by any spacecraft. The measurements provided the first direct evidence of how effective the heliosphere truly is as a cosmic shield and highlighted the challenges future interstellar missions would face when travelling beyond the protective boundary of our star. When the data from Voyager 1 began arriving from beyond the heliopause, it did more than confirm humanity had entered interstellar space. It exposed gaps in long-standing scientific models. For decades, researchers at NASA and other institutions had constructed detailed simulations of how the heliosphere should behave, how the solar wind would slow, how magnetic fields would realign, and how particle densities would transition at the boundary. Yet the actual measurements revealed a far more complex and dynamic environment than predicted. The magnetic field alignment did not shift as dramatically as expected. Plasma densities were higher than many models suggested, and the structure of the boundary appeared less like a sharp dividing line and more like a fluctuating, layered interface shaped by interacting forces. These findings forced scientists to rethink the nature of the Sun's protective bubble and its interaction with the interstellar medium. Instead of a simple pressure balance between two regions, the boundary now appears to involve magnetic draping, turbulence, and energy exchange processes that are not yet fully understood. The heliosphere may stretch and compress in response to galactic conditions, changing shape over time as it moves through different regions of the Milky Way. This realization has profound implications not only for space physics, but also for our understanding of how well the solar system is shielded from galactic radiation. Voyager's discoveries transformed theoretical assumptions into active questions, opening a new frontier where physics must evolve to explain phenomena measured at the very edge of our star's influence, at the very edge of our solar system where the Sun's power fades and the vast ocean of interstellar space begins. Humanity discovered something extraordinary. What was once theory became reality when Voyager 1 crossed the heliopause and revealed that the boundary of our star is not silent, not simple, and not fully understood. The unexpected plasma waves, the mysterious magnetic alignment, the surge of cosmic rays, each discovery shattered assumptions and replaced certainty with deeper questions. The data challenged long-standing models developed by NASA and scientists around the world, proving that even at the limits of our knowledge, the universe still holds surprises powerful enough to rewrite textbooks. This journey is more than a scientific milestone. It is a symbol of human curiosity, refusing to stop at the edge. A machine built in the 1970s now whispers to us from beyond the Sun's protective shield, reminding us that exploration is not about having all the answers. It is about daring to ask bigger questions. The boundary of the solar system is no longer a distant concept. It is a living frontier, and we have touched it. May this story inspire you to push beyond your own boundaries, to question boldly, and to explore fearlessly. Good luck on your journey of discovery, wherever it leads. Thank you for listening, for wondering, and for keeping the spirit of exploration alive.